After several interesting talks about DevOps in culture and technical and security, we now come to today's highlight, to the keynote, and we are glad to have Currie here. Welcome, Anne.
Hi.
And you're in London, so it would have been a very short trip for you if we were all there. But it's great to have you here, and you're also a member of the program committee. And I remember when we had our committee meeting, when we were talking about chaos engineering, and we need something on chaos engineering.
Spoilers.
Yes, I need to do that because it's no. I just want to explain why we chose you for the keynote. And you said, well, wasn't last year a little bit like, and then no, I won't to spoil anything more because I just wanted to say, and you had so many great ideas that we said in the end, wouldn't you be the perfect person to give the keynote on this topic? So you've been in software business for a long time, but I think you saw many new things, as many of us did within the last year. So I'm really looking forward to your keynote, and I won't steal any more of your time or spoil any more of the information and leave the stage to you now.
Thank you. Well, hello. So my name is Anne Currie. And as you've just heard, I have been in the tech industry for a very long time. I've been around for about 25 years as an engineer and as a manager and as a startup founder. But of all of those years, my argument for the talk today is that the most interesting one was 2020. And I think it was the one in which the tech industry, had the greatest impact on the world. And I think it saved, across the world, millions of lives. And that's what I'm going to be talking about today. So we all know that in 2020, we had the experience of the internet collapsing under the weight of lockdown and all of those interminable Zoom calls. And as a result of that, COVID ran rampant, society collapsed. We were all doomed. Millions of people died. But hang on, that didn't happen. Why on earth not? Because actually, there's no reason why it shouldn't have happened, is what I'm going to argue today. And it's a very, very interesting question that we should all be asking ourselves and exploring and talking about far more than we currently are. In fact, we're not really talking about it at all. So we should be talking about it. Why on earth didn't the internet collapse in 2020? Now, in the middle of the year, there was a good quote from John Graham Cunning, the CTO of Cloudflare, the CDN company, who said, "It's hard to imagine another utility, say electricity or water or gas, coping with a sudden and continuous increase in demand of 50%, which is what the internet did." So it's not unreasonable for us to start asking and demanding to know why, so we can make sure that next time we do the same thing. Because for all we know, it was luck. It might have been random events, random chance that we survived, and we need to make sure that we understand that and can work on it. Because so the subject of my talk today is how. How did the internet survive 2020? Obviously, the West internet. It wasn't the internet worldwide that survived, but in the West, how did it survive 2020? Now, the first thing I think we should. The first thing that comes to mind is, well, the internet is a bunch of cables and it's cell towers. If we needed to an extra 50% up our capacity by 50%, we could do that by adding extra network infrastructure. But the trouble is that would be incredibly slow. It would be way too slow. And we need an action in hours, not months. When lockdowns were announced in countries, they were usually announced for a couple of days' time, even a couple of hours' time. They weren't announced for 6 months, enough time for you to lay some new fiber optic infrastructure. So we had to act quickly. So it wasn't putting in new cables. What was it? Now, it's not unreasonable for us to say, was it, for the first question that's on everybody's lips to be, was it the cloud? Because if there is ever a question like this, usually the answer is, it was the cloud. But that seems odd, doesn't it? Because a bunch of cables is not the same as a bunch of servers and storage in a data center. They're very different beasts. But there's reason to start thinking, well, maybe it was the cloud because of how fast we did it. As we all know that the worst thing to need in a hurry is a new cable under the Atlantic, and the best thing is a commodity server in a managed data center. If we managed to accommodate this 50% increase in demand so quickly, that tends to imply that maybe we did it with the cloud, because that is one of the few things in the tech industry that can respond at that speed. Now, we all know that it wasn't smooth sailing under lockdown, and at least initially, certainly in the UK, it was all a bit dodgy and things weren't working quite so well. So we know that we basically held on by our fingertips for the first couple of weeks, and then things got better. But nonetheless, that wasn't enough time to put up a new network of cell towers. So fundamentally, we are looking for something that moved very quickly. So was it the cloud? And it is worth noting that something that I didn't realize, and a lot of people don't always realize, is that a surprising amount of the growth of the internet in recent years has happened inside the data centers of the big three cloud providers. So it's not crazy to think that that might be where it came from. In fact, the telcos have been looking to build their own clouds for years and years now. Most of them have decided not to and have moved into Google or Azure or AWS, because actually it turns out building a cloud, a highly stable, highly resilient cloud, is really quite hard. So a lot of them have given up on doing that and gone to the ones that already exist, which is not an unreasonable, a reasonable decision to make. It's certainly the decision that most of us would make ourselves. But a lot of the growth of the telcos in terms of their own internet infrastructure has happened inside the public clouds. So how could that possibly happen? Because, as I said, servers and storage are not the same as a bunch of cables. And we know that the internet is mostly a bunch of cables and cell towers. So how is a data center a like-for-like replacement for that? Well, let's step back and think about what goes on in a data center. So we've got servers, we've got processing. Well, that's transcoding, the transformation of digital assets from one codec to another codec, and that's usually a downgrade in quality, a downgrade in bandwidth. So we've got transcoding, so that might explain some of it. We've also got, and actually I think that when we think about data centers, we tend to think about servers, but storage is in this story equally, if not more important, buffers. So buffers are an extraordinarily interesting concept in logistics, in physical logistics and in virtual logistics as well. So a buffer, we're going to have to take a moment here for me to have a little love affair with buffers. Buffers are a very simple idea. They are a way of storing something you're transmitting between the source and the final destination. So the most simple example of a buffer, one that you will have used today in your own house, is your kitchen cupboards are buffers. You've got your tin of beans in there. That means that you can just go to your cupboard, get out your tin of beans, make your lunch, and you don't have to go to the local store to get your beans. And the store is a buffer. That means you don't have to go to the supermarket. And the supermarket is a buffer. That means you don't have to go to the farm. And physical buffers are an absolutely key part of physical logistics. Amazon deliveries wouldn't work without them. So they're already an extraordinarily society-changing concept. Simple, but an extraordinary society-changing concept. But when you go to digital buffers, things get even more interesting, because if it's data in the buffer rather than tins of beans, you can create more copies of it. You can instantly create a copy, or more or less instantly create a copy of the data. And then the buffer doesn't just become a temporary storage location, it becomes a new source. And buffers, by decoupling the supply of an asset from its final consumption, they become an interface, which actually works very well with that whole idea that you can use your servers to do transcoding, that what arrives doesn't have to be what's served out. So what arrived from the supplier doesn't have to be what goes out to the final consumer. And again, that can be extraordinarily powerful when it comes to cutting the amount of bandwidth that is required on the internet. So, but all of that's a little bit esoteric. Let's look at a specific example of a service and an architecture that takes advantage of service and storage that are available in the cloud. Now, CDNs, I love CDNs. I'm sure that almost all of us have paid for CDN services at some point in our careers up until now. I know that, so in the first decade of this century, I worked in the e-commerce, pure play e-commerce. I worked for a lingerie company, an online lingerie company called Fig Leaves. And we certainly paid for one of the earliest CDNs, Akamai at the time. And we used that, we paid for that because we wanted the pictures on our website to get to the desktops, and it was desktops back then, of our users quickly, because they were very impatient and would just click away and get bored, and they wouldn't buy the pants that we wanted to sell them. They would go and buy somebody else's pants if the pants didn't get there quickly enough, if the pictures of the pants didn't get there quickly enough. And CDNs were like magic. You know, you paid for a CDN, and then your hero image of a man in a pair of underpants got to your customers much more quickly. But it wasn't magic. It was a magic trick. It appeared that the picture of the man in the underpants got to the users a lot more quickly. But what happened in actual fact is that you moved the picture of the underpants close to the user, and then they all only on demand had to pull it down the short final step. And I've got my next slide is a diagram of the working of a CDN here. Right, so this is how CDNs work. You have a big lot of data goes from the supplier, in this case the Fig Leaves website, to the CDN, and then sometimes smaller copies, not always smaller, but copies of the data move from the CDN to their final destination on the user's desktop. And that's good for the user because it's faster, but it's good for the internet as well, because it reduces the total amount of traffic that has to travel. Instead of sending 5 copies or 100 copies or 5,000 copies of the large chunk of data all the way from your website to your users' devices, you're only sending that giant copy once, the long distance, and then you're sending usually smaller copies, maybe tailored for the user's devices. So they're probably looking at it on a little phone, and maybe it's low definition, and therefore they don't need the full size of the image. But you are basically cutting, and of course I'm talking about images. It was images at the turn of the century. Now it's of course high definition videos or whatever. But the asset, a smaller version of the asset, goes the smaller distance of the final hop, and the overall traffic on the internet is considerably lowered. And in fact, it can be even better than that. The large copy of the data that goes from the supplier to the CDN doesn't even necessarily need to go across the internet at all. I'm sure that most of you have heard of the concept of Netflix boxes. So something that Netflix have been doing since, I think, 2014 is putting all of their output onto a giant hard drive and driving it by truck to the CDN, to CDNs all over the country. So you take all of that bandwidth off the internet backbone and you put it on the freeway instead. It's kind of like an example of that old adage about never underestimate the bandwidth of a station wagon full of videotapes. But fundamentally, you're taking all of that. The architecture of the CDN allows you to take an extraordinarily large amount of data off the physical network. And the physical network, as we've said, is slow and expensive to grow. It's much better if you can avoid it. But that's not the only way that CDNs have stabilized the internet. If a modern CDN acts in quite a significant way, like an SD-WAN, if you've come across that concept, a layer that provides extra intelligence on top of a network that can help route around, that observes what's going on in the network. And this is what CDNs do with the final hop. the final step between themselves and end users. They look at where the internet is struggling, where there's a lot of congestion, and they route around it. So they route around what's often referred to as internet weather. And by doing that, they spread the traffic out. And of course, when I was talking about the big data going across the internet, the CDN, again, that could be used to spread the data around. Even if you don't drive it in a truck like Netflix, even if you do send it over the internet, if you aren't doing it on demand for the customer, if you do it in advance, move it in advance, then you can move it days or weeks earlier at a time when the internet is quiet. And all of this has the effect of spreading out traffic and getting the network utilization up on the internet, which again is good because putting in these cables is expensive and it's slow. So you want to improve the utilization. So it gets the utilization up, it increases stability. So CDNs are, I think, probably the best single example of using servers and storage and data centers to stabilize the internet. But they aren't the only example. But I mean, they're particularly interesting because I know from the Fig Leaves days, you buy a CDN as a person who's paying a CDN customer, a supplier. You buy it for speed. You buy it to get your assets in front of your users faster, and that's all you care about. But as a side effect, it increases the efficiency and resilience of the internet. And it was that in 2020 that actually made quite a big difference to our ability to handle a 50% increase in demand. So I was saying that CDNs are the heroes of this story. Did we all survive 2020 just because of CDNs? Well, no. I mean, they're not even the only example of effectively using servers and storage as a way of taking traffic off the network backbone. But they are just a very good example of it. The clouds themselves are an excellent example of using servers and storage and taking work off the backbone. But CDNs are particularly interesting. I find them a very interesting and effective contributor to 2020. But what else? We talked about CDNs. What else? Did it all happen in the cloud, or did any of it happen anywhere other than the cloud? Well, actually, quite a lot of it did happen. Had nothing to do didn't have anything directly to do with the cloud in the way that I've just described. So a particularly interesting story I found was the Microsoft Azure team. No, not the Microsoft Teams team who are running on Azure. Now they put out a blog post in 2020 about how they had managed to cope with the increased demand on Teams that occurred during 2020. And the thing that they focused on most of all was efficiency upgrades that they had done. Now, I'm sure we've all heard it's almost a cliche to say never prematurely optimize. Don't optimize your systems before you need to. And that's a very sensible, that's a really sensible thing to say and not to do, because if you have unoptimized systems, they do cost more to host. But generally speaking, hosting costs are not the biggest problem your business will usually have. Usually, your problem is developer time, and optimizing systems is often really hard. It takes developer time, so you'd rather pay for the additional hosting than give up any time for your developers to optimize systems. And there's another downside to optimizing systems, which is that an optimized system becomes more complex. It's more difficult to manage, which means it takes more of your engineers' time to look after it, and it's more likely to fall over. It's more fragile. So there are good reasons for not overly optimizing systems. But in a situation like 2020, particularly where you are a cloud provider like Azure, machines and storage become incredibly valuable to you. And you have a lot of unused capacity in systems that have not yet been optimized. And they specifically talked about, and this is a classic one, that the encoding format they were using in their caches was text-based. And obviously, text-based encoding formats really easy to code, really easy to maintain, really easy to read and check the data, but they are huge compared to binary formats. They take a lot more space in your cache, and they take a lot more processing power to write and to read and to manipulate. So one of the big things that the Microsoft Teams team did was to move over from text-based encoding to binary encoding. Now, obviously, when they did that, they then hit the problem that I've just mentioned, which is it makes your system more complex. So they then also had to soup up their testing, and they introduced chaos testing to do that in order to handle the increased complexity of their systems. Efficiency upgrades. You will have unearthed spare capacity in your unoptimized systems, and sometimes it's useful to go in and get that spare capacity. Now, one of the things that interests me as another way that people handled the increase in demand in 2020, bandwidth demand in 2020, was managed service downgrades. It interests me because at the turn of the century, I used to work on video conferencing products for Cisco and various other folk. And video conferencing is what we did during 2020. Obviously, constant wall-to-wall video conferencing. And in some ways, we were very lucky with that because VC systems are extremely bandwidth forgiving. It might not seem that way when you're sitting in front of somebody who's frozen, but actually a frozen image is the way that you forgive bandwidth. A video conferencing system is a classic example of quality of service judgments on packets. It's got audio, and audio is very sensitive to bandwidth and to latency. So that traffic really has to be prioritized. Otherwise, all the people you speak to will sound like they're at the bottom of a well. So you've got to prioritize that traffic, but it's actually quite small. Audio traffic is tiny compared to video traffic. Video traffic is huge, but fortunately, video is quite forgiving. If the person you're talking to in a video conference starts to go a bit blocky or freezes for a while, or you're not going to go bananas, as long as you can still talk to them, generally the system can stay up. You can live with that. You're not going to throw your laptop to the floor and storm out of the house and burn down a police station. Society is going to survive everyone being slightly irritated with the quality of their video conferencing, as long as it's just the video, as long as it's not the audio. So video conferencing is extremely good at handling bandwidth variability, and that saved all our bacon in 2020. But the interesting thing is it's not just video conferencing that's true of. All well-architected applications have to handle variable bandwidth because the internet is flaky. If the internet wasn't flaky, then we wouldn't have put all of these architectural options in place, and we would have been in a lot worse position in 2020 than we were, but more on that later. So I've talked about quite a few things there, a few different things that contributed to the internet staying up in 2020. It's really nice if you can think it would be one thing that saved us all. One 10x developer came up with some whizzy idea and everyone's lives were saved, like in like Iron Man or something. But that was not the case. It was a team effort. It was lots of people doing lots of things in lots of different parts of the industry. And it kind of, when I started to look into this, it kind of reminded me of, I don't know if you've ever seen the TV show Air Crash Investigations. It's quite a good show about the aviation industry and postmortems into air crashes. And the aviation industry is extremely good at doing postmortems. They are fantastically good at getting to the root of crashes, which is why we don't really have very many crashes. And one of the things they learned over time, and they didn't realize this initially, was that it's hardly ever one thing that's gone wrong. Especially as systems get more and more stable, you really don't. You expect there to be one thing might have to go wrong to cause a crash in a fairly unresilient system. But in a multiple resilient system, you would expect lots of things to have to go wrong. And in fact, that was true. It's not just pilot error. It might be pilot error, but it's usually another thing as well. And what I am going to put forward, and we can discuss this later, and I would like to get everybody's thoughts on this, is when things go right, it's probably also not just one thing that goes right. It's not just one clever 10x developer somewhere who had some amazing idea. It's lots of things need to go right in order to have something which is borderline miraculous. That the internet survived a sudden turn on and demand of 50% is borderline miraculous. But we mustn't think of it as miraculous, because we can think of it as figuratively miraculous. We shouldn't think of it as literally miraculous, because it was lots of people doing things that we need to understand and be able to reproduce. So what are the things? I'll just summarize what I've talked about up till now. Overspill capacity in the form of the cloud that was instantly available. And then that wouldn't have been any use unless we had architectures like Cdns that could use that overspill capacity. We had smart downgrade schemes like switching over from people to pictures of cats. Pictures of cats was an excellent downgrade scheme, because really a picture of a cat hardly needs to move at all if you as an avatar for a user. It's a really potentially great way of cutting the bandwidth requirements for a video conference. There was unearthed spare capacity inside under-optimized systems. We all know about the innate stability of the internet. I haven't talked about that, but we all know about it anyway. It has a built-in ability to root around issues and keep going, which is good. But finally, actually, and this is not finally, there were millions of things. People did millions of things to keep the internet going in 2020. These are, I think, some of the top ones, but I'm sure you will be able to think of others. And I want you to be out talking about this, because this was such a win. We need to learn from it, and we need to talk about it. We don't need to just move on as if we all expected it and it was a miracle, because it wasn't. It was a miracle, but it was a figurative miracle, not a literal miracle. The other thing that we won on was that we already had quite a lot of planned room for maneuver. And that was because the internet is so slow to grow, the physical internet, the cables and the cell towers are slow to put in. You have to deliver in advance of demand. You can't do it all just in time. So there's always quite a lot of spare capacity in the system as the planned capacity comes online months or years, even months in advance of if it's being needed. So when we went into 2020, we already had quite a lot of spare capacity on hand in the system, because the internet is constantly expanding and it takes quite a long time to do that. So so there I've listed some of the things that went into why the internet survived. But I want you I want us all, and this includes me, because this is all quite new for me as well. In fact, I felt really quite uncomfortable about giving this talk, because normally I like to talk about things where I feel I have more of a right to talk about it. But I spoke to loads of folk about this subject, and people who were real experts, much more expert than I am in the field. And none of them knew exactly why it was. They all had a little piece of the puzzle. And I thought, well, if nobody feels comfortable talking about it because they only have a piece of the puzzle, then we'll not talk about it. So we do actually need to talk about it, because we need to put these pieces together and learn from them, because there may have been strategic decisions made years ago that allowed the internet to survive 2020. And we need to know what they were so that we can keep making them again. And we need to be looking at strategic decisions that are not specific necessarily to the internet, that can be applied more widely, because we know we've got a lot more difficult problems coming, climate change coming. We're going to have to make an awful lot of difficult architectural decisions around that. And if there's something we can learn from the success in 2020 of the internet in the West, then we need to learn it. We can't afford not to. So think harder on this. And this is where I really want everybody to be putting in ideas and thinking about this and getting involved in the chat. So what were the reasons why the internet survived? The strategic reasons, not just the tactical reasons that I talked about in the last slide. I think the fact that there's a lot of money swilling around made quite a difference. It's a very investable thing, the internet. Because it's strategic for businesses and for countries and even for individuals, and it's growing because we've got this amazing pent-up seemingly endless pent-up customer demand for the internet. It's worth putting money into. So that's meant that it's competitive with a lot of players. And it's also decentralized because that was the way it was designed. It was designed for resilience. So it was designed to be decentralized, which means that a lot of players can compete simultaneously in it. And so you end up with quite a lot of inefficiency and overcapacity and duplication, which, as I've mentioned earlier, although it's very inefficient, does lead to considerable resilience. So if one provider goes down, there are always other providers to go to. You've got lots and lots of alternatives there. And I find this one quite interesting and difficult for me, because normally I speak about climate change and how the internet needs to become more efficient and how we burn too much power and all that kind of stuff. And that's true. But in 2020, it was the inefficiency of the internet that was probably one of the major factors in saving millions of lives. So I don't know how we cope with that. How do we manage the fact that we need it to be inefficient to be resilient, and we need it to be efficient in order for the planet not to spontaneously combust? It's hard. That's something we're going to have to get our heads around. The other thing this came out from having a conversation, although obviously from the conversation we had earlier, it obviously been knocking around in my head as well. Something I talked to one of the experts at Cisco, a chap called Chris Lilienstolper, about when I talked to him about this. He was noodling on the idea that one of the things that kept the internet up in 2020 was that it was a bit crap, that it was flaky, that the change in internet flakiness in 2020 wasn't 0 to 1. It got much worse than usual, but it was an analog increase, not a binary one. So the internet was already crap, and it would fail all the time. So everyone who was going to write applications for the internet had to write them to be resilient to crapness. And that was incredibly useful in 2020, because in 2020 it was more crap than usual. We needed everything to be resilient to crapness. In many ways, the internet, because it's a bit flaky, is a living embodiment of chaos engineering. The idea of chaos engineering, which obviously came from Netflix and talks about by people like Adrian Cockcroft, is that you run your applications on a system where the developers expect there to be outages and know there will be outages. So they have to architect for outages. They have to put in place retries and stepping back and handling themselves crashing and restarts and all that kind of stuff. Because if they don't think they're going to encounter it, they won't architect for that, and then their system will just fall in a heap as soon as they do. There's no way you can run. And I think there are some foolish companies in Northern California who forget that the internet anywhere else in the world is flaky. But any sensible company has to architect for internet flakiness because it is flaky. And without that, their systems, all systems everywhere, would have fallen to a heap in 2020 when it was more flaky than usual, but not a 0 to 1 change. So we're talking there about investment, we're talking about crapness, we're talking about inefficiency, and lots of minds on a problem. But was it just that? Was it just the tech industry that caused the internet to survive 2020? I would argue no, because we were very lucky that the COVID pandemic happened in 2020, not in 2010. Because if it had happened 10 years earlier, there would not have been enough capacity in the system. And the internet has huge capacity these days. There would not have been the capacity, I don't think, 10 years ago for all the clever folk in the world to have come up with all kinds of schemes for making it extend. Well, for one thing, the cloud didn't exist in the same form back then, but even if it had, we couldn't have met the demand based on the resources that we had then, no matter how clever we were. But we have an awful lot more resources now. And the reason we have an awful lot more resources in internet resources in 2020 than we did in 2010 was because of the extraordinary demand for internet bandwidth that has occurred over the past decade. And what was behind that demand more than anything else, it wasn't Zoom calls, it was streamed TV. Because we know that streamed video just requires shed loads of bandwidth because it's not forgiving. It requires extraordinarily large amounts of bandwidth. And people really wanted to pay for that bandwidth because they wanted to watch Game of Thrones and Netflix and all of these other shows that were available. So they poured tons of money into the internet. Investors poured tons of money into the internet. The cables and the wires, they grew. And so the internet is much, much larger now than it was 10 years ago. So I'm going to leave you with a thought here, although I really wanted to follow up afterwards. And I do have a little bit of homework after this point. That was the world saved in 2020? Were millions of lives worldwide saved by Game of Thrones, which would go a long way towards making up for a very disappointing final season. So your homework after this talk is to go away and have a think about this and talk about it, because I think we all need to be talking about it. And I'm amazed that we're not, because there's so much to learn here. That's your main piece of homework, and we'll start it in the conversation after I finish talking. Your other piece of homework is I'm also the writer of a series of science fiction novels. And I put the first one on free promotion today on Amazon. So if you search for Utopia 5 on Amazon, you will be able to download it for free just for today. So that's your homework. Go and do that. So thank you very much. It's the end of my talk.
Thank you, Anne. Very great talk. I think there are no questions or comments yet. I hope there will be some. So after you told me that you did the drawing in the back yourself, did you do the covers of your novels as well?
I did.
Yeah, great. So you're a multi-talent, and but I think your talk, the idea of the efficiency and inefficiency. So the balance of it is just what saved us all. It's kind of hard to understand because it's as you said, it's not 0 to 1, and software developers tend to think in zeros or ones. So it's really a new way of thinking, and it really opens your mind. I think it's great, and I would love to see some comments now on the chat. It would be really great if some of you would give. You don't have to ask questions, just share your ideas. We're still waiting for
Everyone's in stunned silence at my talk. Well, they might. Hopefully, everybody's away buying my book before they forget.
Yeah. Sure, but yeah, you had a lot of culture in there, as you had Game of Thrones as a world saver. So they had a lot of virtual people had to die for a lot of real people's life to be saved. So better kill virtual people in novels or TV shows than in and save real life.
Yes, there's a strange similarity there, isn't there? I don't have Netflix, but I did really like Game of Thrones, and although I have just signed up to Netflix yesterday, I finally ran out of all the things to watch on all the other on Amazon and the BBC. But it probably was Netflix more than Game of Thrones, if I'm being really, really honest. But I
probably yes.
Probably was.
Yeah,
you know what I mean.
Yeah.
Know what I mean.
Yeah, if it doesn't stream good enough, if you have hiccups on your stream, you don't want to watch the show, and then so you're no longer a Netflix customer. So all those streaming. Now there comes some feedback. Well, one is I'm still mind-boggling your chain of thoughts. Yeah, that's I can fully agree to that. And the second one is first, amazing homework. Second, awesome presentation style. Third, mind is blown again.
That's the trouble. I should have. So I gave this talk because I'm also a lecturer these days in tech ethics at the University of Hertfordshire, and I gave this talk to my students on last Wednesday to try it out, and I did get quite a lot of comments from them. So I will say that they were better at asking the questions. Maybe they're younger than all of us.
They're younger and they're expecting good grades from you, which is one thing is to think Netflix used to use the postal service for bandwidth, and now there are coming more questions up. Just copy them over, as I said before. I need a larger font than the chat font, so I can read without wearing my glasses. Do you think the growth over the last decade, based on the massive overinvestment in fiber, etc., of the late 90s, early zeros, that we finally benefited from the dot-com bust?
Well, actually, that's a very good point to make. Well, because I was working on video and data conferencing at that time, at the turn of the century, as I like to refer it to. Refer to it as and even with the dot-com boom, the bandwidth was crap. It was really terrible compared to now. It was as nothing compared to the idea of stream TV at that point was it was just like we didn't even really, to be honest, do very much video conferencing. It was mostly data conferencing, and you attempted to do that with the tiniest number of bytes you could possibly imagine. I think it really is Netflix that has driven the enormous increase in bandwidth. Because I mean, obviously all those Zoom calls we had every day, we did that borrowing the bandwidth that in the evenings was used for stream TV. And it was stream TV that was the reason why the bandwidth existed. I really do think that's the case. Which I don't know how I feel about that. I think I feel happy that in some ways it was actually a cultural thing that was the underlying driver of our survival, rather than just technology. And we always talk about it as being technology, but it was culture as well.
And maybe do you think online gaming as well has some impact on it, because there's latency issues? They're way worse than for streaming, because once the stream is running, it's fine. If you have some hiccups there, but for online gaming, once you're running around and you have a lack of half a second, you're basically done with the game.
Yeah, no, I think you're right. Online gaming is as much of a feature as I just had to pick one or the other.
Yeah.
And I'm more of a Game of Thrones person than a Fortnite person. But yes, yeah. And in fact, with the last time I gave this talk on Wednesday, I was pulled up on the fact that the internet did completely collapse in Italy for a while, apparently caused by overplaying of Fortnite. So the children of Italy did bring Italy to its knees.
To be fair, I am I play video games, but I'm more in the Final Fantasy business, so I don't know really for about that. But I got that, yeah. And
right, that was correct. That point, both those points were very good. I think that it started with the internet boom. All of these things roll forward, don't they? And then games were as much of a contributor as Game of Thrones.
The next comment is interesting and thought-provoking. Thank you, Anne. I would also argue that the forward planning to use IPv6 helped us to survive in 2020. Would you agree? Also, is crapness an adjective?
It's my adjective for the internet, but in a good way. Crapness in a good way. It's like a chaos monkey. It's a live chaos monkey that we paid a huge amount of money for. Oh yes. So the original question was, what was the original question? I got
Uh,
distracted with the
the
crapness.
IPv6 would
Yeah,
help us to survive in 2020. Wouldn't you agree?
well, it's actually, I don't know. I would have thought so, because that sounds like a very good observation. I'm aware that now that it comes to mention it, it never came up. I spoke to loads and loads of people who are much more expert in the current internet setup than me for this,
Hmm.
and nobody mentioned IPv6, which it might have been because they were just assuming it, and therefore it's all done and dusted. Therefore, it just didn't really appear as an issue. But I will have to go off and find out about that. What role did IPv6 play in the survival of the internet in 2020? That is an excellent question.
That's good for you to get some feedback there. So you have
Yes.
for our next talk, you have some additional thoughts in there. And then this next one thought, though, made container, Kubernetes, and similar technologies reacting to those changing demands also faster, or at least laid a partially foundation?
I would like to say yes, but my suspicion is that it didn't make a huge, I don't know whether it made a huge amount of difference. There aren't that many people, even now, who are really, really good at using Kubernetes. So, and if you're not, it can make your systems less stable. And it also, and Kubernetes and particularly Istio,
Mhm.
these service meshes, they are very, very, very resource intensive, and not necessarily in a good way. They aren't kind of inefficient in a way that means you can easily unravel it and get the efficiency out. And also they're not duplicating anything. They're just using. They're like Bitcoin mining on your own systems. Like Istio just uses a huge amount of power to run.
Mhm.
So and not power, because power wasn't necessarily the issue in 2020, but server capacity was. So all of these things that use a lot of server capacity, I don't know. It's. I would love to say nice things about it, but they come in for a bit of a kicking in some of my other talks.
Well, we have a Kubernetes day on Wednesday. Maybe I can convince you. The next one is, again, it starts with love the talk. My takeaway is that there wasn't really a business case to invest in the resilient infrastructure needed to survive 2020, but there was a business case for people to move from expensive TV services to streaming. Maybe resilience needs more creative business models.
I think that's as an excellent point as well. That the next problem we have is climate change and electricity grids.
Yeah.
And if there's one thing we've learned from 2020, it's that consumer demand drives growth more than anything else. It was consumer demand for Fortnite and Game of Thrones, and other services do exist, that made the internet so valuable that everybody doubly, trebly invested in it. So we had overcapacity and we had duplicated systems, and therefore we had inefficiency but resilience as a result of that. We need to have a think about how we're going to get that same effect with green electricity, because it's not clear at the moment that people are willing to pay for green electricity, but maybe they're just not being offered it in the right way. If we can market it properly, we need that level of demand. Consumer
Actually,
demand is really what changes the world.
I think that's a very good point and very important one, because we also just started on Heise Developer a column on sustainability and how do you, as a software developer, how can you work against the climate change, not only by using green. There was the most recent column, not only by using green power, but also by writing software that is more efficient and uses less power, because all those little changes, there's so much software running. So all those really small changes really add up. So I think that's a good point you got there. And as the next one, it might be from Google. I'm not sure if Netflix is the sole survivor and would like to promote YouTube for pushing video on demand, called by the youth in 2000 until 2010 as the new television, promoting entertainment online, including Let's Play and promoting gaming.
No, sounds like an advert for Google.
Yeah, that's what I was wondering. It doesn't show
Yes.
here. No.
Say other
Maybe it's
services
just a
doing
YouTube
this.
fan,
It's not all
because
Game of Thrones. If,
I
to be honest, I'm doing quite a favour to Sky by saying it was them, because it wasn't. It was. Let's face it, mostly Netflix. Although YouTube and other things did also contribute. And
I
Fortnite.
have a 27-year-old son, and he watches way more YouTube than any other medium. And well, at my age, I hardly watch any YouTube at all. Usually, it's just those instruction videos we get for some news release where you say, "Oh, let's learn about the next release of Kotlin." Oh, there's a YouTube video. That's where I click YouTube. But that's it for me. It's a generation thing, I think.
I think that's true as well. We're all old. We don't watch lots. As I'm exactly the same.
I'm old. You're you're not. Okay. And I think that were a lot of great comments. Thank you all to the audience for getting involved in the talk, and thank you, Anne, for giving us such an interesting talk that the people wanted to get involved. It was really good choice to have you for a keynote speaker, and I think it was a good close-up of day one. Good talk about chaos engineering and the mind-boggling. Well, we have to work with this all ourselves. Thank you very much.
Cheerio. Thank you very much for having me.